Hello, Algebra 2. Tonight's topic is 7.4, solving rational equations. And we have two essential questions tonight, or two objectives. And the first is, how do I solve rational equations? And the second is, how do I apply this knowledge to real life? So starting off, there's three different ways we're going to be using to solve rational expressions. And the first way is to show you when you have two fractions equal to each other. The fastest way, the most simplest, is to use cross multiplication. And if you look at number 1, you can see how there's two fractions. They must be only a fraction on one side equal to the other. And so as 2 is like that, and 3 and 4. But if you look at the example number 5, we could not, the first step could not be cross multiplying. We'd have to use some other steps first. So let's go ahead and try number 1. And we're going to start by cross multiplying. And then number 2, step 2 would be distribute and simplify and solve for the variable. Step 3 would be check. You can have extraneous solutions with these problems, so you want to make sure you check. And last, you're going to write the solution. So if you remember back from geometry and algebra 1, cross multiplying again is only when you have one fraction equal to the other, and you're going to take one numerator and multiply by the other denominator, and the one numerator multiply by the other one. So cross multiplying is just what it sounds. So we have 3 times x and 9 times 8. So 9 times 8 is 72. And then you just solve for x. In this case, we'll divide by 3, and we get x equals 24. Now it's important to check. We could have an answer that's not a true statement, so we want to check. So if we plug in 24 to our x to check, you can see that it is this true statement. 9 divided by 24 could be simplified to 3/8. So that is a true statement. Okay. For number 2, we're going to go ahead and cross multiply. So we have 5 times x plus 3 equal to our 7 times 2. Okay, go ahead and simplify that and bring it back. When you multiply that through and solve for x, you end up here getting 5x equals -1, so you divide by 5, and x is equal to -1/5. You're going to go ahead and now check it. So plug in -1/5 into x and check to see if you get a true statement. Okay, so when you plug in -1/5, you end up having 7 divided by -1/5 plus 3 equals 5/2. And we have to simplify this rational expression to see if we get 5/2. So first you combine the denominator, make sure it's one fraction, and that would 3 would be equal to 15 over 5, which would, if we add these two, would be 14 over 5. So then you have 7 divided by 14 over 5. And it's probably easier to write it like that, 7 divided by 14 over 5. And then multiply by the reciprocal, and you can see that 7 over 14 would simplify to 1/2, and that would be equal to 5/2. Okay, number 3, I want you to go ahead and try on your own. Go ahead and cross multiply and check your answer. So when you cross multiply, you should have 5 times 2x plus 1 equals 1 times 4 minus x. Now you distribute, simplify, and solve. And when you do that, you get 10x plus 5 equals 4 minus x. Then you bring all the x's to one side and all the constants to the other. And you would end up solving for x, you would get -1 divided by 11. Now you need to check, make sure it's a not an extraneous solution. So go ahead and try that, plug that in and check. So with your check, you'd have two places to plug it in. So 2 times our x plus 1 on the denominator here, and here it was 4 minus our x, so it would be 4 minus and -1 over 11 would be 4 plus that. So then again, you have to simplify your fractions, combine denominators, and this side would simplify to 1 over 9 divided by 11. Here we simplify to 5 divided by 45 over 11. Then we multiply by the reciprocal, and we see that they are equivalent. 11 ninths does equal 11 ninths, because there's a factor of 5 and 45, so it would be 11 over 9. Okay, one more before we try another method, and I'm going to go ahead and change colors. Let's do red. So we're just going to cross multiply here. 3 times 4 minus x equals 2 times x minus 4. We go ahead and multiply that through. 12 minus 3x equals to 2x minus 8. And then we combine like terms. I'm going to go ahead and add 3x. So actually we're moving the like terms to one side. So first I'm going to add 3x to both sides. And then I'm also at the same time going to add 8 to both sides. That would cancel that to 0 and leave this to 5x. Here that would become 0, and that would equal 20. Then we would divide by 5, and we get x equals 4. Now in all cases this seems like a great answer, right? We didn't get a fraction this time. But when we go to check, if you plug in 4 for both of these x's, you will see this is where you're getting your extraneous solution. You have 2 over 4 minus 4. You can't have 2 divided by 0. That's impossible. You can't divide by 0. Remember, that's a no solution. So, and the other side as well, 3 over 4 minus 4, that's 0. So that's no solution. We can't divide by 0. So when we plug in our 4, if we get a impossible thing or not a true statement, then we'll have no solution. It's our extraneous solution. We can't divide by 0 here, so there's no solution. X equals 4 is not a solution. Okay. Now, when we don't have two fractions equal to each other, the fastest way is going to look to try to clear all our fractions. And our steps are listed here. If our equations need to be factored, that's going to be the best way to find our common denominator, and that's going to be first. Then we're going to multiply each side by the least common denominator. Then we'll distribute and solve. And last, we'll check for and make sure our solutions aren't extraneous, and then we'll write the solutions. So we've been working on the pairs check for least common denominator. Go ahead and pause and see if you can come up with the least common denominator for number 5 and number 6. Okay, so if I had to add all these, my least common denominator would be 12. For all our denominators, 4 and 6, the least common denominator would be 12. For number 6, our least common denominator would be 8x. But for both of these problems, we are not trying to add them. We're trying to solve for x. We're trying to find the fastest way to find out what x is. So this time we're going to be using that least common denominator to help us clear our fractions. We're going to be multiplying each side by it so we can clear our fractions. We want to get rid of all those fractions as quick as we can. So I'm going to go ahead and multiply 12 by everything in my equation. So we have 12 times 1 over 4 minus 12 times negative x, and then 12 times x over 6. Twelve divided by 4 would simplify to 3. And then 12 divided by 6 would be simplified to 2. And that made our problem a lot simpler. We got rid of all our fractions. If whatever you picked didn't simplify everything, then try again. That's our goal here, is get rid of all our fractions. Okay, go ahead and solve for x and check it. Okay, so you should get x equals 3 over 14. And your check, remember you have to plug in 3 over 14 to 2 different places, and it should show that it is a true statement. Alright, I want you to go ahead and try number 6. Your first step again is to multiply 8x by everything here, and then solve for x after you've cleared all the fractions. So when you follow the steps, you'll get x equals 8, and then you will see that it is a true. Okay, there's one other way to try these problems, and that's using technology. So I want you to go ahead and write down these steps for using technology when you're solving rational expressions in equations. You can use it for solving any equation for systems, but go ahead and start by writing down these steps. Alright, so this problem can be used, also you could factor this denominator and find the common denominator and then clear the fractions, but I want to show you how to use technology as well. So you're going to place one side of the equation in y1. So I'm going to put this left side here of the equation in y1, and then the other side of the equation into y2. So it's just going to be 1. Anytime you have rational expressions, you must use parentheses as you put them in. Then we're going to look for the intersections by hitting these steps, and I'm going to go ahead and pull up my calculator here. So notice how I put in my equations, my rational expression or fractions with parentheses. Both the numerator and denominators must have those in them. So there's the left side and there's the right side. Then we're going to hit second, trace, and then 5 for intersections. And then we want to do the intersection close to the two places. So go ahead and try that. So one intersection I see here, so first curve, I'll put it there and hit enter. Then a second curve, and then I'll move the cursor near there. And the first one they found was 7.29. So go ahead and write that. The second intersection is in this section, so again you have to go through the process again, and you would get negative 3.29. Okay, so the last thing I want to talk about is how this applies to real life. So take a minute and read through these steps. Our first problem, we're going to be talking about Jeremy cleaning the whiteboard and Katie also cleaning the whiteboard. What we want to find out, or x, is how long it takes them to clean the board together. So we have two people that we want to equal one job, and we're going to represent this as a ratio of their time together over alone. So for Jeremy, it's x over 4. For Katie, it's x over 3. And then we're going to solve for x. When you do that, you get 1